Hello everyone, welcome to Regular Electrician YouTube channel. Today's video will be learning how to work with encoders. Today we have one incremental encoder and we're going to talk about how the incremental encoder works and how to troubleshoot and do day-to-day activity in the encoder. So today we're gonna go step by step. Introduction first, how the encoder works or what type of encoder you have, then how to check the encoder with the multimeter, how it's functioning, or troubleshooting, and how to troubleshoot with oscilloscope. So we'll be going one by one. How it works. Inside the encoder is a disk with transparent and opaque sections for optical type and magnetic pole for magnetic types. A sensor detects the interruptions. Each interruption is a pulse. The system uses pulse count to know the rotation and angle, time between the pulses to calculate the speed, and phase difference between A and B channel to know the directions. Based on output signals, we segregate sensor into two types, incremental and absolute. Incremental encoders. Incremental encoder produces a series of square wave pulses, record a reference point to calculate absolute position, simpler, cheaper, commonly used for speed and relative positioning. Absolute encoders. Absolute encoders provides a unique digital value for each position. No need for reference point. Retains position after power off. More complex and more expensive, but highly reliable for exact positioning. Technically, incremental encoder, every time when you restart, you need to give your reference back, otherwise it will go to zero pulse. In the other side, absolute encoders, wherever you stop, whenever you get the power back, it will show the exact position because the pulse coming from absolute encoder or the data coming from absolute encoders are fixed based on the encoder position. Based on motion, we can separate encoders into two types, rotary and linear type. Incremental rotary encoder outputs pulses as the shaft rotates. It gives relative position, speed, and direction. Absolute rotary encoders, each position corresponds to a unique digital code, so it provides exact shaft position even after power loss. Linear encoders. Linear type encoders measure straight line displacement, position, and speed, often used in CNC machines, measuring instruments. Again, so rotary encoders are monitoring the rotational moments. Linear encoders are monitoring the linear movement or flat movements, straight movements. There are different sensing technologies used in the encoders. Major technologies are optical, magnetic, capacitive, and inductive. Optical encoders. Encoders use light beam and a coded disc to detect the movement. High resolution, widely used technology. Magnetic encoders uses a magnetic and Hall effect sensors, works well in harsh and dirty environments. Capacitive encoders. Capacitive encoders uses changes in capacitance, less common but resistant to dust and moisture. Inductive encoders. Inductive encoders works well on electromagnetic induction, very robust in industrial environments. Types of encoder. There are different type of encoder based on the application. The major types are multi-tone, single-tone, linear scale, and resolvers. Multi-tone encoders are used where you need multiple rotation to be calculated, and single-tones are just single-tone about 360-degree maximum they can read. Linear scale encoders using in different applications like CNC milling, drilling, and measuring tools. Resolvers are analog encoders similar to the other encoder, but outputs are analog, very rugged for extreme conditions. There are different type of encoder signal output. Common encoder signal types are open collector, push-pull, RS442 differential line driver, RS485, analog sign and cosine, TTL, and HTL. In today's our topic, we gonna talk about incremental encoder, optical type, rotary type with HTL signal. This is a common example of an encoder internal path. You will have different lights with different angle or orientation to detect the pulse. Here you can see red and green for A pulses and your blue for Z pulses. You can see in the disk there you have many holes. That's your pulses. Number of pulses based on that. And in Z pulse you have only one per revolution. That's what they call index pulse, or it's a home pulse for to understand your home position. An example of a quadrature pulse encoder. Here you have A and A bar, B bar, and C bar. Each of them have a positive side and an inverted side. You can see here in 360-degree there are four 90-degree partitions. In each partition you can see a phase shift or a changes in the pulse phases. That's where the rotation and directions are calculated. Here is the trick. This is how the encoder understands you are in positive direction or negative direction. For let's say your encoder moving in the clockwise and you are in the sequence of 1 0. So your A in a 1 and 0, B in 0. Your channel A in 1 and channel B in 0. What is 1 is you have a positive volt, whatever is based on your encoder, and the channel B has a 0 volt at this point. Then if you move again clockwise, the next count you're gonna get is 1 1. Both channel will have voltage in the positive phase. But if you go from 1 0 to 0 0, this will be your negative side. You're going counterclockwise. These four codes are used to determine the direction of your encoders. Technically, you can identify each 90-degree one direction change. This is a pure example of your encoder pulse with your oscilloscope or multimeter. You can see A and A bar. So A, when A in 0 volts, your A negative will be in 24 volts. We're considering here is a 24 volt signal output encoder as an HTL type. So when you have 0 volt in A, you have 24 volt in B, A negative. When you have 0 volt in A, 24 volt in A negative. When you have 24 volt in A, you have 0 volt in A negative. This is how the inverted pulse are working. Either A or B, you will have one time one voltage, not in both place voltage. Either you have an A or A naught. That's how the square wave inverted pulse are generated. So whenever you look with your encoder, if you want to verify that your both channels are up, you can put in stop position A and A negative. You will get exactly the voltage what you need, 24 or 12 5, depends on your encoder type. If one of your channel broke, you may not get this voltage, and if you start moving the encoder, you will see this 24 volt will invert and come back. You can see negative 24 or positive 24. These are very sensitive. There are not all the time you can identify them, but slow movements can give you this positive negative shifting. That's how you can identify that your channels are okay and it's giving feedback, which doesn't inquire it's gonna work, but yes, at least you are sure that your wire broke not happened. Yeah. First, a little bit discussion about an incremental encoder. Generally, incremental encoders are pulse generator. They're giving feedback through pulses. And this particular encoder what we have here is 1024 volt, 1024 pulse and 24 volt output. And you can see the connections here. You have your 24 volt in, 0 volt, channel A, channel B, channel A negative, channel B negative, channel Z negative. So these all are individual pulses, and today we gonna look how we can troubleshoot them. Okay, so first we will learn how to connect them, then after we'll be looking with how to troubleshoot with multimeter and with oscilloscope. First of all, your connections. Yes, in connection you have input. Input is your 24 volt and 0 volt in. Then you have three type of output, A, B and C, and all they have inverted pulse. So inverted pulse. Okay, so A have A negative, B have B negative and C has C negative. So we'll see how we can work with them or how we can troubleshoot with them for the functionality of encoder. Okay, as a standard troubleshoot, first we need to verify the power is coming to the encoder. To do that, you need a multimeter with two probes. Here we have a multimeter and oscilloscope built in together, so we'll be using that one. You can see the voltage. So we're gonna check the supply voltage, just disconnect the fuse and check the input. As you can see here, it's 22.23 volts supply to the encoder. Now what we need to do is we need to look the return channel. So once you give power to the encoder, you need to verify that your encoder is functioning or not. To do that, what we do generally, we take the channels. So in our case we have channel A, channel B and channel Z or Z. Yes, so we look one by one. So to verify your one channel, you can do what? You can take the multimeter and connect to channel A and A negative. So you are getting 21.76 volt, which means your channel is good. You will have a little drop than your supply voltage actually from the encoder. And channel B, same way we look. Yes, it has 21 volt. It's negative, but we'll talk about that later. So it's 21 volts. And now the Z. Z also you have 21 volts, 21.87. So okay, now we will go and look channel A. Okay, we are clear with the multimeter. So if you see these and these, which means your encoder is healthy, almost you have power here. Now the function what you need to look is, are they functioning? So you can see that while rotating the encoder, you will have inverted pulses coming back and forth. You can see that now it's 21 positive, then after some time it may come negative 21. You can see that. It's negative. So these are called inverted pulse because one time it's go positive and negative there and here. Okay. today's video we are going to stop here. Next video will be learning how to scope the encoder and to see different type of encoder pulses with noise, without noise, and in live experience. Thank you for watching. Wait for the next video for to see more about encoders.